For section 2 out of chapter 1, so section 1.2, we're going to talk about limits, and we're actually going to finish out this whole chapter talking about limits. So what is a limit? Basically, a limit is the y value that you're sneaking really close to as you sneak close to your given x value from the left and from the right. Okay, so it's not necessarily if I substituted an x, what y will pop out. What I want to know is what's happening infinitely close to my x value. As I get really, really, really close to it, what y value am I getting really, really, really close to? So we're going to do this a few different ways. We're going to do this graphically, meaning I'm going to use a picture. Okay, we're going to do this with a table. And again, that's where the table feature of your calculator is going to come in real handy. Okay, so either with a graph or with a table, or we're going to use direct substitution, which is going to be algebraically. Okay, and it's just, any one of these will work. It just depends on your context. How is it set up? But traditionally, what I'm going to be asking you for the rest of the semester is, can you use direct substitution? Because if you can, that's going to be your fastest way out. So if I can use direct substitution, that's what I'm going to do. Oh no, my pen died. All right, if, holy cow, come on. All right, if direct substitution doesn't work, can I factor and reduce? Is that an option? Can I rationalize? So all of these come underneath that. So basically, or is it a special form? Special form. But what we're going to do first of all is just kind of explore what it is. Okay. So again, we've got graphically, which is with a picture. We've got a table, which means we're going to use values that are really, really close to our target x and see what y value we sneak up to. Or can we just use algebra, which is going to end up being probably our easiest way a vast majority of the time. But here we go. So what we have is, I have the limit, and something you're going to get sick of me saying as well, is math people are very lazy. So I'm not going to say the limit and spell it out because it's too hard to write the I and the T. So this says the limit, and then it says as x approaches, so where's my x going? I am heading towards a 4, okay? So my limit as x approaches 4 of, and then my formula is going to be an x minus 4 over an x squared minus 5x plus 4, okay? So this is my function. So if I use direct substitution, it'll pop out y values. So first of all, let's see what happens, okay? Because again, direct substitution is usually going to be your fastest way out. So if I evaluate with a 4 minus 4, and again, I'm getting this 4 from here. Okay, so 4 minus 4 is 0 over 4 squared is 16 minus 20 is negative 4 plus 4 is 0. So 0 over 0, this is going to be the first time theoretically that you've seen this. You've always seen 0 divided by a number, or you've seen a number divided by 0 where those numbers aren't 0. But theoretically, this is the first time that you've ever seen a 0 in your numerator and in your denominator. And this is called an indeterminate form, and you're going to actually play with that more in Cal 2. But for right now, you need to recognize I don't have enough information to give you this answer. Okay, I can't say it's 0, and I can't say it's undefined, because I've got two different answers hitting in the same thing. So what that means is I'm going to go ahead and use my table feature. And again, this is what it's asking you to do. So do you see, I'm going to shove in a 39, a 399, and a 3999. So what I'm doing is I'm sneaking really, really close to my x value of 4, and I'm coming at it from the left because these numbers are smaller than 4. And then I'm going to do the same thing. I'm going to come at it from the right because these numbers are bigger than 4. So what's going to happen is that as I get closer and closer and closer, these two numbers should end up being either the same or essentially the same. Okay, so here's what I'm going to do in my calculator. I'm going to go to y equals and clear this out. So if you've got the new software, you can hit alpha and then y equals and hit enter. And that'll just put everything in a fraction for you. If you don't have it, then use parentheses around your numerator, divided by parentheses around your denominator. So I've got an x minus 4 over, oops, what did I just do? See, what am I talking about? All right, x minus 4 over x squared minus 5x plus 4. Okay, so why am I putting this into my y equals? Because I can go to my table. And remember, always make sure that your table set, your independent, which is your x's, needs to be set to ask. So go to your table and then start shoving these values in. So from the other day, from when I was making videos, these are still in there. So just type over them. I've got a 3.9. I got a 3.99. I got a 3.999. So hopefully that makes sense. You're sneaking closer to 4 from the left, but you're not actually using 4. And then from the right, we're going to go 4.001, 4.01. Oop, what am I doing? Goodness, what is happening? All right. And then 4.01, and then 4.1. Okay. So what happens when I look at this? For 3.9, I get 0.34483. Okay. So 0.34483. Now, it says round it to 4 decimal places, and I just rounded it to 5. Okay, WebAssign, you're going to have to pay attention at this point because you're not estimating. So WebAssign should actually demand a correct answer on that one. And so round it to 0.3448. Okay, so the next one says at 399, I've got 3345. So 3345. At 3.999, I've got 3334. So 3334. Now, look at the fun part that happens if I actually shove in a 4. If I say, well, what happens? I get an error. Okay, it's not going to let you see. It's not going to let you, it's not going to figure it out because it's indeterminate. All right, so let's, for 4.001, I got 33322. So 3332. And then for this one, for 4.01, I got 3322. So 3322. And then 3226. So 3226. So basically what this means is this. As I sneak towards 4 from the left, what y value am I creeping up to? And this is 3334. As I sneak up to this from the right, what y value am I sneaking up to? And that's a 3332. So what's in between 3334 and 3332? I bet it is 3333, which is 1/3. Okay, so my limit is 1/3. So here's the fun part. Are you ready? What happens if I don't want to use the table feature? What happens, because obviously tables are a little bit detailed and kind of irritating to use. So what happens if I go back to here just for kicks and I say, hey, I am going to try and use algebra for this. So what happens if I factor the bottom? So I actually have x minus 4 and then x minus 4 x plus 1, or x minus 1, good heavens. Okay, x minus 4 over x minus 4 times x minus 1. So follow my train here. I tried direct substitution and it didn't work. So now I'm going to try and factor and reduce. Okay, so I have factored this, and any number divided by itself is 1. So that means my new function is the limit as x approaches 4 of 1 over x minus 1. Can you use direct substitution now? Why, yes, I can. Because if I shove in a 4, 1 over 4 minus 1 is 1/3. Okay, so we didn't have to do all the table stuff. But you're going to have to do the table stuff because it's a legitimate way to find limits. Okay, so let's do a couple more. For number 2, this is going to be another thing when you're going into Cal 2 that you're going to need to remember. Okay, so first of all, remember that 0 over 0 is called indeterminate. Indeterminate. Okay, it's indeterminate. You don't know the answer because it's a weird setup. So now look at this one. I've got the limit as x goes to 0 or the limit as x approaches 0, of 3 times the sine of x over x. Okay, so again, even though I know I'm going to have to be using this table, I still want to see if I can use direct substitution because I'm trying to practice. Part of my job is to teach you critical thinking skills, which means I want you to find the fastest, most efficient way to solve a problem. All right, so if I give you a 0 for x, what happens if you shove this in? So I have a 3 times the sine of 0 over 0. Well, what's the sine of 0? It is 0. So 3 times 0 over 0 is going to give me a 0 over 0. So this is an issue. I'm back to having an indeterminate form. But remember this little setup here where you've got the sine of x over x, or you have x over the sine of x. Okay, this is going to be a little trick. It's one of those things that you watch out for because when it pops up, you're going to immediately know the answer later on. Okay, so if I've got x over the sine of x or the sine of x over x, that's going to be a special thing, and this only works when you're going to 0. So it's a very special case, but it ends up saving you time in the long run. All right, so what happens if I shove this stuff in here? So I have, going back to my y equals, I'm going to clear this out, and I've got 3 times the sine of x over x. So I didn't use the fraction this time, I just typed it in. And then go to your table, and I've got a negative 0.1. I've got a negative 0.01. I've got a negative 0.001, and then I hop on the other side, and I've got a positive 0.001. I've got a positive 1, or 0.1, and a positive 1. Okay, so what are you getting close to? Your top answer, I don't know if you can see this. Hang on. Dun, 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 dun. All right, is that better? I don't even know. Okay, so the top answer is 29995. Well, if I scroll up, you're going to see that these round. I can highlight them and I can see that they round out to a different number. Okay, so you're still going to want to plop those in there, but you should recognize that as I'm creeping closer to an x value of 0 from the left, I'm approaching 3. And as I creep up to an x value of 0 from the right, I'm creeping up to a 3. Okay, so your answer on this is going to be my limit is 3, but you're going to have to enter those boxes. I'm not going to do that for you. So here's the question. Do you see a pattern? If I have 3 sine of x over x, and my limit is going to 0, and my answer is 3, then I wonder if there's any correlation between my coefficients. So you're going to see why that works in Cal 2, but for right now, just if you've got coefficients, that's going to be your answer. All right, so this one you can do on your own. Be very, very careful when you enter that into your calculator. So I would use parentheses here and parentheses here over parentheses there. Okay, so use the table feature. What is this black thing? All right, so now let's move on. Hang on, I want to check and see real quick if there's any other tables. I don't think that there are. All right, so what we're going to do is I'm going to make another video about using the graphs, and then we're going to do some epsilon delta proofs in the last video, which are the fun ones. All right, so that is that video, so you can get started at least